Section 5.1, we're going to talk about inverse functions. I'm going to build a little table here. C and F. Anybody know what C and F stand for? Celsius and Fahrenheit. Very good. So, when does water freeze? What temperature? 32 Fahrenheit. What's the freezing temperature for water in Celsius? 0. And when does water boil? 212 Fahrenheit. What about Celsius? 100. Okay, so there's a little table. I've given you 2 points. One point is 0, 32. The other point is 100, 212. I want you to find the linear equation that matches that data. So in order to find the linear equation, this goes back a ways. We haven't done this in a while. What's that? y2 minus y1 over x2 minus x1. First thing you need to do is find the slope. Perfect. So m would be, normally we would use y2 minus y1, but in this case we're not using x's and y's, we're using c's and f's. So which letter is pretending to be y and which letter is pretending to be x? C is x and y is f. How do you know? In order. X has always come first, y has always come second. Simple as that. So this is going to be 212 minus 32 over 100 minus 0. What's 212 minus 32? How much? 180 over 100. 180 over 100 reduces to be 1.8. I'm going to call it 9/5. Because I can certainly cancel out a 10, can't I? I can cancel out a 10 on top and bottom. So then it's 18 over 10. I can reduce by 2. That's 9/5. So that's my slope. Now that I know the slope, how do I find the equation of the line? I already have the y-intercept. In this case, it's actually the f-intercept. How do you know you have the f-intercept? Because it's 0, something. So I can use y equals mx plus b. But again, we're not using y's and x's. So it really should be f equals mc plus b. So my equation would be f equals 9/5 c plus 32. Okay, so what would that formula be useful for? If somebody told you the Celsius temperature, you could pretty easily convert it to Fahrenheit, couldn't you? So, for example, let's say I gave you a new Celsius temperature. Oh, I don't know. Somebody pick a temperature. Anybody got a number they like? 54. So, you're traveling in Europe, and you get up in the morning and you watch the weather, and they say the temperature is going to be 54. Should you be wearing shorts and a t-shirt, or should you get out your winter jacket? Winter jacket? All right, well, let's plug 54 in and see what we have. F would be 9/5 times 54 plus 32. You grab your calculator. And you type that up. 9/5 times 54 plus 32. It's going to be 129.2 degrees Fahrenheit. I don't think you want that winter jacket. That's going to be awful hot. Okay, so that formula is really pretty useful if I give you the Celsius temperature and I want the Fahrenheit. But what if I go the other way? What if I give you a Fahrenheit temperature What if I tell you the Fahrenheit temperature is, I don't know. Anybody got a good number? 78. So now somebody is visiting us from Europe, and they get up in the morning and they see the temperature is going to be 78. And that doesn't have a lot of meaning to them because they're used to dealing with Celsius. If the Fahrenheit temperature is 78, what would the Celsius temperature be? Well, we just plug it in, right? So we would have 78 equals 9/5 C plus 32. And how would you solve that equation? Solve for C. So you begin by subtract 32. 78 minus 32 is 46 equals 9/5 C. And then how do you get the C all by itself? Divide by 9/5. How do you divide by 9/5? How do you divide by a fraction? Flip and multiply. So I'm not going to divide by 9/5. I'm going to multiply by 5/9. I'm just going to flip and multiply. So the answer would be C is 5/9 times 46. 25.5 bar degrees. Now, using this formula that we have, F equals 9/5 C plus 32, was it easier to plug in a C number and figure it out? Or was it easier to plug in an F number and figure it out? It was easier to plug in a C number, wasn't it? Why was it easier to plug in a C number? Because it's already set up for that, isn't it? F is already by itself. If I plug in the C number, all I had to do is grab my calculator and type it up. If I want to plug in an F number, I had to plug in an F number and then I had to do a couple steps to solve. Not a lot harder, but a little bit harder. Now, what if I told you, I'm going to make you plug in a whole bunch of F numbers now. I'm going to force you to plug in 18, -9, and -40. What would you do? Well, let's look at what happens. Again, I'm going to write down my formula. F equals 9/5 C plus 32. Let's say I plug in 18. So I could have 18 equals 9/5 C plus 32. What do you need to do? And how do you solve for C? You subtract 32. What's 18 minus 32? -14 equals 9/5 C. And then, to get C all by itself, multiply by 5/9. So C is -14 times 5/9, -7.7 bar. How did the steps in those two problems differ? In this case, I told you F was 78. In this case, I told you F was 18. What did we do for both problems? We subtracted 32 for both problems, and then we divided by the 9/5, which we decided to multiply by 5/9. Instead of continuing to plug more and more numbers in, maybe it would be easier to just do it in general. Let's say I were to take F equals 9/5 C plus 32, and I told you, take that equation and just get C all by itself. How would you take that equation and get C all by itself? Minus 32. So you would have F minus 32 equals 9/5 C, and divide by 5/9. And dividing by 5/9 is the same as multiplying by 9/5. No, multiply by 5/9, which is the same as dividing by 9/5. So our answer would be 5/9 times f minus 32 equals c. Now for what we want to do, I think that formula is more useful. If I want to plug in f numbers, I think this formula is more useful than the original formula we came up with. Why is this one more useful? All I have to do is plug in numbers and then grab my calculator. So if I told you, plug in now, f is -9, all I got to do is grab my calculator and plug in right here. So I take -9 minus 32, and then I multiply by 5/9. And I would have -22.7 bar. And then I could plug in -40. I could plug -40 into this formula. And I don't have to do any more solving. It's already worked out. Now, -40 is an interesting one. Anybody know why -40 is an interesting temperature? Because it's also -40 Celsius. Try it. Plug it in. -40 Fahrenheit is exactly the same as -40 Celsius. That's what makes -40 an interesting temperature. It's the same in either scale. All right, but here's what we have. Here's the whole idea behind this section. We have two functions here. We have f equals, we had 9/5 c plus 32. And then we have c equals 5/9 times f minus 32. For the first function, what's the input? Input is the x numbers. So the first function, what's the input? C. And what's the output? F. What happens in this function? It flips them. The inputs become F and the outputs become C. And when that happens, these are called inverse functions. You flip the x's with the y's, basically. This one has input of C, output of F. This one's completely the opposite. This one has input of F, output of C, and those are known as inverses. Depending on what you want to do, sometimes it's better to have the function this way, written this way. If you want to plug in a bunch of C numbers and figure out the F numbers, having the function written this way is better. Conversely, if you want to plug in a bunch of F numbers and find the C values, this form is more useful. Okay? Questions on that? Okay, so I'm going to give you a function here. It's going to make up a generic old function here. F of x. And I'm going to tell you the x values and the y values. I don't know. Give me 4 x numbers. 6, 8, 12, and 23. And the y numbers are going to be -4, 7, 19, and -100. Is that a function? I said it is. Is it a function?
Yes.
Yes, that is a function. How come? No repeats on the x values. Very good. Now I'm going to write the inverse function. And the symbol we use for inverse function looks like this. And it's not a symbol I'm real fond of, because it looks a lot like an exponent. But when I write this symbol, when I'm using function notation and I write the symbol, I do not mean exponent there. What I mean is function inverse. Correct. To be a function, the x numbers cannot repeat. What's the inverse function going to be? What do you mean by opposite? Instead of 6 and negative 4, I'm going to have negative 4 and 6. And instead of 8 and 7, I'm going to have 7 and 8. 19, 12, negative 123. There would be the inverse function. So what does the inverse function do? It's a mirror image. It switches the x's and the y's. It switches the inputs with the outputs. It switches the domain and range. There's lots of ways I can say that. That would be the inverse function. This inverse, is it a function? Yes, it is a function. How come this inverse is a function? None of the x's repeat, do they? All right, here's another function, g of x. G of x is, I don't know, again, somebody make up some x numbers for me. Ten. 20. 30. 40. I thought maybe there was a pattern there. My y numbers are going to be 5, 10, 15, and 5. That one doesn't follow the pattern. Okay, so now I'm going to come over here and I'm going to write the inverse. The inverse would have x is 5, y is 10, x is 10, y is 20, x is 15, y is 30, x is 5, y is 40. Excellent. This is not a function. Why is that not a function? Because in this one, x equals 5 repeats, doesn't it? Okay, so how come for f of x up here, how come f of x when I found its inverse it was a function, but when I started with g of x when I found its inverse it was not a function? Because of the y's. So g of x is a function because none of the x numbers repeat, correct? Unfortunately, one of the y numbers repeated because I made it repeat because I wanted it to. So what happened when I found the inverse? It meant the x number repeats. And so the inverse, there is an inverse, but it's only a relation. It's not a function. So what has to happen? If I start with a function, when will its inverse also be a function? When there's no repeats in the y. Okay, so a function will have an inverse that is a function when there are no y values repeated. And there's actually a name for that. There's a name for a function that doesn't have any repeated y values. So let's say function is called 1, 2, 1. Why would we call a function that has no y values repeated 1 to 1? What's that? One number goes to one number and one number only. So this function here, this g function is not 1 to 1, or this g function is not 1 to 1 because 10 is matched with 5 and 40 is matched with 5. 40 is matched with two things. It's not matched with one thing. That's what we mean by 1 to 1. Everything's matched with exactly one thing. That doesn't happen with g. So does g have an inverse? G does have an inverse, but its inverse is not a function. Its inverse is only a relation.
So, both of them are wrong?
It's not that it's wrong. It said it's not a function. So this is a function. G would be a function because no x value repeats. G inverse is not a function because the 5s repeat. It's what we would call a relation. It's not as good. What we really want to start with a function, do its inverse, and end up with a function. And so in order for that to happen, to start with a function and have its inverse be a function, no y numbers can repeat. If a y number repeats, then you're not going to have a function. Not a bad thing. Just in general, we want functions.
So, is this going to be used more for different problems? Is that why?
Yes. So, first off, let's do a little bit more with inverses, and then we'll look at some problems in the homework here. Let f of x equal 4x minus 8. Is that a function? Yes, in fact, it's a special kind of function. What special kind of function is that?
Different.
Begins with an L. Linear. That's a linear function. How do you know that's a linear function? It fits exactly into y equals mx plus b. That's a linear function. What I want you to do is I want you to find the inverse of that function. How do you do that? You flip them around. That's exactly right. So instead of writing the letter f of x, instead of writing that symbol, I'm going to write the letter y. Just because it's easier to write. What does the inverse do? What did we do to find? It does what? True. Well, actually, I'm going to get y by itself here in a minute. What does the inverse do? It switches the... doesn't switch the signs. What did we switch back here on this table? We switched the x's with the y's, didn't we? So if I had my original function, in order to find the inverse, all I did is I switched the x and the y. So if I give you a function written this way, to find its inverse, what you're going to do is you're going to switch the x with the y. So I'm going to write x equals 4y minus 8. And then what I need to do to find the inverse function is I need to get y all by itself. How do I get y all by itself? I add 8. So x plus 8 equals 4y. And then divide by 4. And when I divide by 4, I have to make sure I divide everything by 4. So y is 1/4 x plus 2. So my answer would be the inverse is 1/4 x plus 2. Questions on that one?
On the test, will you give formulas on this?
Well, there's not really a formula here.
Well, for like 6.5.
Oh, for 6.5 and 6.6? You mean this formula? And that formula? Those formulas will be given to you on the test. Yes, you do not need to memorize those two formulas. This one was a plus b times a squared minus ab plus b squared. And this one was a minus b, a squared plus ab plus b squared. I will give those two formulas to you on the test. You do not need to memorize them. All right, back to inverses. G of x equals 4 over x plus 2. Is that a linear function? No, that one's definitely not a linear function, but it is a function. If I plug in an x number, I only get one answer for y. And I want you to find G inverse of x. Well, again, we start the same way. To find G inverse, we write down y equals 4 over x plus 2. We write y, then it is G of x. Then what do I do?
X equals 4 over y.
Switch the x and the y. X equals 4 over y plus 2. Now I need to take that equation and I need to get y all by itself. What am I going to do? Multiply by? Multiply by y plus 2. Why do I want to multiply by y plus 2? I want to get rid of the fraction. I have an equation and my equation has a fraction in it. If I have an equation and my equation has a fraction in it, in order to solve, I'm going to multiply both sides by y plus 2. So I'm going to have y plus 2 times x equals 4. You have an equation with a fraction and you're trying to solve that equation. Clear the fractions. Multiply by the common denominator. Now what? It wouldn't be subtract x. You got the right idea. That's a multiply right there. How do you get rid of a multiply? Divide. So I'm going to divide by x. So y plus 2 is 4 divided by x. And then finally, to get the y all by itself, minus 2. Y equals 4 over x minus 2. So there would be our inverse. Our final answer would be G inverse of x is 4 over x minus 2. Questions on that? Inverses have an interesting graphing property. Well, at least I find it interesting. Y equals, let's see, I think we had a minute ago, we had 4x minus 8 was our f of x. And then what did we decide the inverse was? I think it was 1/4 x plus 2. Is that right? Yeah. There's what those two graphs look like. Well, what's interesting about that? Anything? Not particularly. However, I'm going to draw a third equation. Y equals x. What can you tell me? What's that? It does bisect them. That's true. And so what that means is there's a reflection property. If I could cut my calculator screen right along this line y equals x and fold it over, what would happen? They would line up exactly together. And that's called a symmetry property, where you can, if you can flip the graph over and get the same picture on both sides, if I could cut right along y equals x and flip that graph over, it'd be exactly the same picture. Okay, so I'm going to give you a function. I'm going to give you a function and a picture. And I'll give you some points on this function. This is the point right here. This is -6, -2. And this one's -2, 0. This one's 0, 1. And this one is 4, 5. And that's my function f of x. Well, I called it a function. Is that graph really a function? Yes. Why? It passes the vertical line test. If I draw a vertical line anywhere, how many times will it hit that graph? Exactly once. What I want you to do, or at least tell me how to do it, Draw the inverse. How would I draw the inverse? Any ideas? Switch all the x's and the y's. So on the inverse, I'm not going to have the point -6, -2. What point am I going to have? -2, -6. So -2, -6 is going to be down here. I'm not going to have the point -2, 0. I'm going to have 0, -2. Instead of 0, 1, I'm going to have 1, 0. And finally, instead of 4, 5, I'm going to have 5, 4. My scaling's not very good. My scaling's not very good is what happened. But what should happen, if I were to draw the line y equals x, the line y equals x would be right about here. It should look like the red and the blue should look like a mirror image of each other. Do they look like a mirror image of each other? Well, I think they would if I'd have used graph paper and drawn a more accurate graph. But you get the idea. They should look like a mirror image of each other. Questions on that? All right, the last problem of the day. Let's get one out of the book here. So in this problem, they give you a table. Percent of births outside of marriage. And it says, in exercise 15 of homework 2.2, you found an equation close to P equals 0.77T minus 43.18 that models the percent P of births outside the marriage T years since 1990. Or since 1900. You remember doing that problem? No. Oh, okay. At least you're honest there. Okay, but the idea is here, they're giving us a table, and from the table, we ended up with an equation. So the equation, and they tell us what the equation is. The equation is P equals f of t is 0.77t minus 43.18. And t is time since 1900, and P is percent. P is the same as f of t. Okay, part A, it says, find an equation for f inverse of x. F of t is 0.77t minus 43.18. No, I just put a decimal point in the wrong spot. Ignore that right there. All right, how do I find the inverse of this function? Okay, well, in this case, I'm going to set it to p because they already called it p for me. So instead of using y, I'm just going to use p. Would it be wrong to use y? No. But I'm going to use p since they already gave me the letter p. P for percent, 0.77t minus 43.18. Now what do I do? Flip T and P. So T equals 0.77T minus 43.18. 0.77P, thank you. How do I get the P all by itself? Add 43.8. So T plus 43.18 equals 0.77p. And then divide. So I think I'm just going to write this as P equals T plus 43.18 over 0.77. I don't think I'll mess with those decimals too much yet. Okay, so we have, this is now F inverse of T is T plus 43.18 divided by 0.77. No, I'm just going to leave it like that for now. I think in a minute here I'm going to be plugging some numbers in. But now we need to be very careful because things get confusing. In the original problem, T stood for what? Time since 1900. And P stood for percent. What happens when we find the inverse? They switch. So T, this is kind of weird, T no longer stands for time. T now stands for percent. Kind of strange, right? So I think what I'd rather do, I'd rather write it this way. I think I'd rather write F inverse of P equals P plus 43.18 over 0.77. Because that would make more sense to me. Okay, so when we deal with inverses, when we deal with word problems, we do that quite often. I don't really want to use T to stand for percent because that's going to confuse me somewhere down the road. Percent should use the letter P, so we will use the letter P there. Okay? So watch out for that. F inverse of T, that's a correct answer, but then it gets confusing. T in the original problem was time. T in the inverse would be percent. And I don't think you want to call T percent. Bad symbol. Part B. It asks you to find F at 100. F at 100. So what does that mean to do? Plug 100 in the original problem. So I just plug 100 into the original problem. I'm just going to grab my calculator. 100 times 0.77 minus 43.18. That's 33.82. What does it mean in this situation? What does it mean to put 100 in right there? 100 years, because T here was years, 100 years since 1900. So basically in the year 2000, 33.8% of children are born out of marriage. So in 2000, 33.82% born out of marriage. That's an estimation. It might be a lot higher than that. I don't know. I'm not going to make any guesses on that. Part C. Find F inverse at 100. So how do I find F inverse at 100? Okay, so I'm going to just take 100 and plug it into this formula, right? So that's going to be 100 plus 43.18 divided by 0.77. So I'm going to grab my calculator again. 100 plus 43.18 divided by 0.77. Calculator tells me I'm going to call that 186. It's about 186. It's 185.9 something, something, something. We'll call it 186. What does that number mean? So what does this 100 mean this time? 100% of children will be born out of wedlock in the year 2086. That's what this tells me. 100% born out of marriage in 2086. Seems like it might be true. I would be surprised if that turns out to be true. Of course, that means that marriage has more or less gone away. It would mean that nobody who is married is having kids. I find that hard to believe.
I don't know.
You don't know? You're not so convinced? You're okay with doing away with marriage?
I think it's kind of starting to get that.
Starting to get that way. All right. Questions?